I think we are live now. Let's read the RFC1320. It's about MD5. No, sorry, MD4. It's an hashing algorithm, message digest algorithm. Let's read about it. It's written by R. Rivest. Ron Rivest. He is one of the R's from the famous RS algorithm, the public key cryptography. Table of contents, terminology notation, okay, algorithm description. We can also try to quickly implement it in code. This document describes MD4 arbitrary length input and produces a 128-bit fingerprint. So its digest length is 128 bit 128 bit of the input. It is conjectured that it is computationally infeasible to produce two messages having same digest. Okay, so this is around the time of 1992. They did not have enough computational power to even break MD5 at that time. The algorithm for digital signature applications were a large file. Okay, just imagine some legal document being forged today using by breaking MD4. The MD4 algorithm is designed to be fast on 32-bit machines. Okay, does not require large substitution table. I don't know what a substitution table is. The algorithm can be coded quite compactly. Nice. It replaces the RFC from October 1990. Okay, the main difference is that the reference implementation of MD4 in appendix is more portable. Okay, I think I don't need to read about this terminology. A word is 32-bit and a byte is a 8-bit quantity. Okay, byte is 8-bit. So 128 bits is 16 bytes. Yeah, yeah, 16. So a sequence of bits can be interpreted in a neutral manner as a sequence of bytes, where each consecutive group of 8 is interpreted as a byte with a higher order, most significant listed first. Okay. Similarly, a sequence of bytes can be interpreted as a sequence of 32-bit words, where each consecutive group of 4 words is interpreted as a word within the lower order bytes given first. Okay, so they are going from 0th bit and on the right to the 31st bit on the left. X subscript I and then X superscript I plus addition, that is okay. They are working with 32-bit integers. Cool. 32-bit value by ordering circularly x by s bit positions. Okay, this is the left shift operator, not bitwise. Okay, these are normal Boolean algebra. The most interesting part, algorithm description. Okay, we begin to suppose that we have a b bit message which is an arbitrary length, and that we wish to find its message digest. B is an arbitrary length, non-negative integer. B may be 0. Okay, 0 to b minus 1. Step 1 is to append the padding bits. The message is padded so that its length is congruent to 448 modulo 512. Congruent to 448 modulo 512, it means that when the length is modded by 512, it should give a result of 448. 64 bits shy of being a multiple of, yeah. Padding is always performed even if the length of message is already congruent to 448. Okay, always pad, always pad. Padding is performed as follows: a single 1 bit is appended at the last, and then zeros are appended so that the length is congruent. Alright. In all, at least 1 bit and at most 512 bits are appended. We need to do the padding. I think at this point we can start writing the code for padding. I'd do it in C, or maybe I can do it in JavaScript first and then convert it to it in C. This takes a string as an input. Okay, let's work with bits first. So my input would be something like 100101010110101, and I get output in a similar way. Okay, so you need to pad. We need to find out the length of which the pad has to be added. For that we need to find, let's store the length of the input. Or I can, the input can be an array as well. Array of ones and zeros. Okay, and then my pad length would be 64 bits shy of being a multiple of 512 bits long. Padding is always performed even if the length is already congruent to 500. Okay, this doesn't matter. This should be 64 bits shy of being a multiple of 512 bits long. Const pad length would be length of the input modulo 512 whatever we get. We for example, the length for this, let's say 100 is my length, or maybe 100 plus 512 would be 612 is my length. Now when I mod my length 612 by 612 mod 512, this is an 100, but it should give me a value of 448. So I am shy of what is 612 minus 448, 164. So how would we get 164 from this is Okay, so if I subtract this number from 448, I get the pad length. Yeah, is it right? Pad an input of um, here I know the answer for 100 should be 338 348, and same for 612, it should be 348. No, I don't know how to create an array. Okay, repeat this for 100 times, and then 612 times. I should get the same number. Okay, I think the padding function is good. Now we move on to the next step. The padding is performed as follows. Uh, a single 1 bit is appended to the message, and then 0 bits are appended so that the length. Okay, so whatever the pad length is, the first bit should be 1 and the rest remain 0. So I can do this by pad array equal to array dot from what was that syntax again? Array dot from. Okay, so that would be zero dot repeat pad length. And now the first pad array should the zeroth element of the pad array should be 1, and we can now add this to our final array. Array dot from input. I can destructure this into a separate array, and then my pad array. Okay, let's console log this final array. I'll give an input of 100 1000 1101. Final array dot to string. Oh my god, this is. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters as it is for the first, that is the message. 11, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the first bit is 1, and the rest all should be 0, which is correct. Append length, a 64-bit representation of B before the is appended to the result of previous step. Is appended to the result of previous step in the unlikely event that B is greater than, then only the lower order 64 bits of B are used. These bits are appended as two 32-bit words and appended lower order first in accordance with the previous conventions. A 64-bit representation of B. What is 64 into 8? 512 is appended to the result of previous step. So the message comes first or the append length come first? What do they mean by append here? Resulting message after padding with bits and with B has a length that is exact multiple of 512 bits. Equivalently, this message has a length that is an exact multiple of 16 words. N is multiple of 16. So I'm not exactly sure if the word, what do they want to what do they want to say? Does the word comes first, or does the message come first, or does the append come first? We can continue reading. At this point, the resulting message after padding with bits and with B, let's see, the message is extended. The message is extended so that the length is congruent to, okay, that is, the message is extended so that it is just, and it is extended in such a way that, okay, so the first thing is appending the padding bits, and then we add the whole result to the word. A 64-bit representation of B is appended to the result of previous step. So this is the previous step. Let's return an array from here. Why is my font like this? I don't have brew installed. Okay, until this gets installed, let's continue. A 64-bit representation of B is added if the message is greater than 2 raised to 64. 2 raised to 64, so that's quite a big number. Then only the lower order 64 bits of B are used. 64 bits is okay. The total number of bits is 2 raised to 64. So how many characters is that? That is 2 raised to 63 characters. No, sorry. 2 raised to 61 characters. Is it? I don't think so. What did I say? If the total number of bits are 2 raised to 64, we have a bunch of 2 raised to 64 bits. When we arrange them in byte, we divide it by 8. So 2 raised to 61. So we have 2 raised to 61 characters long string. These bits are appended as two 32-bit words and appended lower order word first in accordance with the previous conventions. At this point, the resulting message after padding with bits and with the B, 64-bit representation of B. Brew is installed. Let me check Fira.